All right, Mathletes, here's 2.3, properties of functions. First thing we're going to talk about is increasing, decreasing, and constant functions. And we can think of increasing as places on our graph that have slopes that are positive. Okay. Decreasing is where we have slopes that are negative, and constant functions as slopes being equal to 0. Okay. So we have some understanding here. If we're talking about increasing graphs, okay, we can call this x value here x1, which is less than this x value down here, which is x2, and these y values, so this y value here is going to be f of x1, and this y value is going to be f of x2. So we can see when this is an increasing graph, that our x1 is less than x2, and that our x2 is larger than our x1. That is an increasing graph. Now for a decreasing graph, things that have a negative slope, we can see this is going to be a decreasing graph. Notice our x1, let's call this x1, where that is less than our x2 over here. We can see that our f of x1, this y value, f of x1, is greater than our y value here of f of x2. Okay. Our constant slope is where we have a slope of 0, where all of our y values are the same. And we can see there is our constant slope. All right, so on this graph, we're asked to determine where the function is increasing and decreasing or constant. So I am getting a decreasing function from here from -3 or -4 to -3. So on the interval from -4 to -3, it is decreasing and also decreasing here. From 2 to 3 is also decreasing. Okay, so I can see that the graph is increasing here at that interval. So from the interval from -3 to 2, I have a increasing graph. Okay. All right, the next thing here we're going to talk about is local maximums and local minimums. They're pretty intuitive when you're thinking about it. A local maximum is just as if you zoom in and onto a graph, it's going to be a place where you have a maximum. So as you can see down here, this would be a local maximum within this region. It's a point at the very top here of the crest. That would be our local maximum. A local minimum, again, if we just localize and just focus on a local area and we see a point that is a minimum, that is a local minimum. Notice it's going from decreasing to increasing. That is local minimum. For here, you're going from increasing to decreasing. That gives you a local maximum. So at what numbers, so when we're saying numbers, at what x's, if any, does f have a local maximum? Here's our local maximum. So at x equals 1, we have a local maximum. What are the local maximum? Well, that local maximum is when f is 1, we get a y value of 2. So that is correlating to that point. At what numbers, if any, does f have a local minimum? Well, local minimums, we're going to have these two here. So when x is equal to -1 and when x is equal to 3. You can have multiple local maxima and local minimums, and frankly, you could have infinite amount of them. Okay, but on this one, we have two local minimums at -1 and -3. What are the local minimums? Well, at f of -1, I have a minimum value of 1, and at f of 3, I have a local minimum of 0. Okay, so the intervals on which f is increasing. All right, so increasing is a positive slope. So as I'm thinking of positive slopes, I'm looking from here to here, here to there. So my intervals from when it's increasing is from -1 to 1 and from 3 to infinity, assuming that that arrow is just pointing up and positive forever there. This intervals on which it's decreasing. So we are decreasing here. We have a negative slope. Okay, we can think of if we're driving a car from left to right and we're going downhill, that's decreasing. Decreasing here as well. So on the intervals, so from -infinity to -1, it's decreasing, and it's also decreasing on the intervals from 1 to 3. All right, so let's see what else. So use the graphing calculator to graph the following function. So here we're going to use our graphing calculator to make this easier. All right, first thing I want to do is I want to make sure I put in my y equals, I'm going to type in my function. From there, I want to make sure I'm on the right interval. So to change my interval, I'm going to go to window here. And I'm just going to assume my y's from -10 to 10 are going to be okay. But I want my x interval here from -3 to 2. So now when I graph this, I see that I have a local maximum, a local minimum, and another local maximum there. Now in order to find these, I can use a feature on my calculator. Up here by F4, you have calc. So to get that feature, you got to do second, calc. And you want to find, first we're going to find the tip here. And that's going to be a local maximum. So I want to go down to 4, local maximum. It's going to ask me for a left bound. So that's left of your local maximum. So I'm going to scroll over until I get my cursor left. And it doesn't matter how far left, but it just has to be left. And then hit enter. It's going to ask for a right bound location. So as long as I'm right of that, so there I'm right of that local maximum, and a guess, try and get it close to the peak there, and my calculator will go ahead and tell me my local maximum. And so I'm going to have a local maximum at x being -2.04, just go out to 2 decimal places, and a y value being 2.81. Okay, we have a local minimum we'll do next. Okay, and that's going to be right here on my graph. Okay, so local minimum, same kind of calc features. I go to second, calc. I'm going to go to minimum, 3. And so I'm already left bound of this minimum here. So I'm just going to go ahead and hit enter. And I'm going to scroll over until I am right of that local minimum. And once I see it, yep, I'm starting to increase there. So I'm going to go ahead and say I am right of that local minimum. I hit enter. And I guess somewhere over here. And hit enter. And I'm going to get my local minimum value there at x being, well, this is 7.04 times 10 to the -7th. We're going to go ahead and be all right with that being 0, because we got 6 zeros followed by 7 decimal places. So we're going to leave that being 0, and our y is going to be -2 for our local minimum. So again, the next little hump here is going to be a local maximum. So we'll go ahead and find that. Again, second calc. Find that maximum. I'm already left bound, hit enter, go over until I'm right bound. Hit enter, and I guess right about there. And I'm going to have my second local maximum there at 1.10, comma, negative 1.07. So when is the graph increasing? So the graph's going to be increasing on this interval, positive slope, this interval from there. So it's increasing from negative infinity. So the x value of that local maximum was negative 2.04. So it's increasing there. And then the second interval that I have. So that started here where that local minimum was. So that's from, so that is from 0 to where this second local maximum started, 1.10. And those are my intervals for increasing. My decreasing function is going to be here and there. So it's going to be decreasing. It's picking up where this one left over, negative 2.04. And then it's going to pick up where this one left off at 0. And then the last bit of it is from 1.10 to infinity. I don't see anywhere where this function's constant here. So next we got to talk about the average rate of change. We can think of average rate of change as slope. We're just going to be finding the slope between 2 points. In calculus, this is called the difference quotient. So let's go ahead and look at an example here. So find the average rate of change of f of x equals x squared minus 2x plus 3. Notice it's a quadratic. We don't have a constant slope of this. At each point along this parabola, we have a different slope. So we're going to find average rate of change between specific points. Okay, so our equation, we have to find our y's and our x's. Okay, so it's delta y over delta x. So if I'm going from negative 1 to 1, well, my x's are already given to me, negative 1 minus 1, right? My slope formula, I'm doing that. So then the second piece is my change in y's. So to get my change in y's, I have to do f of negative 1. Well, f of negative 1 is negative 1 squared minus 2 times negative 1 plus 3. Well, this is going to be 1 plus 2 plus 3 is equal to 6. So at negative 1, I can see that I'm here at 6. Okay, so that correlates to my negative 1 minus my f of 1. So that's going to be equal to 1 squared minus 2 times 1 plus 3 is equal to 1 minus 2 plus 3, which is equal to 2. So at 1, I'm 2. So I want to know what is the slope or average rate of change of the line connecting these two. So here I get 4 over negative 2. I have a slope of negative 2. Okay, so we'll do this one more time. We'll skip B. Let's just go ahead to C. So from 2 to 5. So from 2 to 5, what is my average rate of change? I should expect a positive slope. So change in y over change in x. So this is always nice because it's just 2 minus 5. Then f of 2, my y at 2, is going to be 2 squared minus 2 times 2 plus 3. I get 4 minus 4 plus 3. I'm at 3. Then I have f of 5 is equal to 5 squared minus 2 times 5 plus 3 equals 25 minus 10 plus 3 is 18. So I get negative 15 over negative 3, which is equal to 5. So I got a slope of 5 to that point. So that is how you go about finding the average rate of change. So like I drew before, that rate of change, that slope, is going to be a line, a slope of a line connecting those 2 points. Those 2 points and that line connecting them is called the secant line. All it is a line containing those 2 points. And understand that the average rate of change, the slope of that line, and the difference quotients, they all mean the same thing. So don't get confused with that. So let's look at an example here. So suppose that f of x equals x squared plus 1. Find the average rate of change from negative 1 to x. All right, so here to find our average rate of change from negative 1 to x, because it is involving x, our answer is going to be an equation, not an actual value. So remember, change in y over your change in x. Okay, so then I'm going to do, well, I want to know what the y value is at negative 1. So f at negative 1 is equal to negative 1 squared plus 1, which is equal to 2. So that's my y value. So at, I'm going to start with my x. So I'm going to have x minus the negative 1. Okay, and then my function at x is x squared plus 1. And then I have to subtract the y value of negative 1, which is 2. So at this point, I get x squared minus 1 over x plus 1. So now this will be a function that will tell me any secant line connecting negative 1 to any other value. So part 2 says, well, find that value from negative 1 to 2. So now I know that my x is equal to 2. I use my previous equation. So I do 2 squared minus 1 over 2 plus 1, and I get 4 minus 1 is 3, 2 plus 1 is 3, so I have a slope of 1. Okay, let's find the equation of the secant line containing this. Remember, I know these points. F of negative 1 is negative 1, 2. And that's all I really need to know for this, because I can use my point slope form. And I can do y minus 2 equals 1 times x plus 1. And I can simplify this out and add 2 to both sides. So then my final equation is y equals x plus 3. So this should be the secant line containing the points negative 1, 2. When I plug in 2 for f of x, so f of 2 is equal to 2 squared plus 1, which is 5. So as I put this into my graphing calculator, my y equals, I put x squared plus 1. And the second part, I put my secant line, x plus 3. So as you can see, when I graph, it's a secant line. So if I trace at negative 1, it's a secant line at negative 1, 2, connecting it to the point at 2, 5. All right. So go ahead and highlight notes and questions you have on notes tonight, and that wraps it up.